Welcome to my webinar. Today we're going to be talking about how to help students make sense of math and become stronger mathematicians. I'm going to tell you about a few strategies that I have found very successful to use in the classroom for students to really own their learning of math and really get to understand what math is about by using visual representations, concrete manipulatives, and then ideally moving into a more abstract understanding of mathematics. My name is Kathy Romero, and I've been teaching for 30 years. I'm originally from Mexico, and where I was a homeroom teacher, I taught all the way from kindergarten and several grade levels up to grade 9. Then I moved to Chile, to the international school in Santiago, where I had the opportunity to work as a gifted and talented teacher. And that's where I really fell in love with teaching math and understanding how you can go really deep into making sense of a problem and using numbers flexible and just making math such a fun thing to learn about that goes above and beyond just memorizing and learning rules and formulas. After that, I moved to China and I was in an international school there. And I worked as a learning support teacher for mathematics as well as an instructional coach for mathematics. Right now, I live in Bangkok and I am a middle school math teacher. I also do some consulting in a few schools in Asia, specifically in Southeast Asia. And what I'm going to do today in this webinar and what I do when I go visit these schools is I share some of the strategies that I have used in the classroom that are very successful for helping students really get an understanding, a deep understanding of what math really is. And what are some parts of the lesson that really allow students to problem solve, that allow them to communicate and reason their thinking to really own that learning and make it their own. This is my family. I have a set of twins, Billy and Anna Sophia, and my husband Michael. We all are right now here in Bangkok. And that's why this is such a great opportunity for me to participate in this webinar for ISAT. I hope you enjoy it and have some post-it notes ready for some work that we're going to do together during this hour. And of course, if you have some questions, I will be happy to answer them at the end. I'll give you my website so you can post your questions there. So this is the agenda for today. We're going to start with a number talk, just like I always like to start my math lessons with a number talk. We're going to start this session with one. Then we're going to move into talking about what are the different elements for a balanced approach to teaching and learning math. And then we'll move into exploring the upside down approach or the student-centered approach. It's also called a problem-solving approach. And the importance of modeling in mathematics. That's one thing that we're going to talk about. At the end, we're going to try and do a little bit of the progressions of strategies to build understanding in math. If we don't have time for that, then I'll just give you all of the resources so you can take a look at that on your own. All right. And I always like to use this image from the NISA Center. And it's just important for us to understand that we are all here at different levels. So it's important for us to identify where are you? Where are you in this understanding of mathematics? Push yourself to the next level and be vulnerable. There might be things that you've heard about and you are ready to implement in your classroom. Perhaps there are things that you are already doing, so it'll be good for you to freshen up and just hear the main goals for those different strategies and make sure that you are using them appropriately in your classroom. Perhaps you're here just to see what this is about. You're happy with the way you're teaching math. You're happy with how your students are responding, and you just want to know what is all this fuss about conceptual understanding and using a different approach. Here are just a few places where you can find me and a little bit of the work I do. So if you're a Twitter fan, please follow me on Twitter. You can scan these QR code for a Padlet. I have a few Padlets with a variety of resources you could use in the classroom. So go ahead and scan that. And then I have my blog. You can just type making sense of mathematics.com and it should show up on your search engine. Let's get started with a number talk. All right. Solve in your head, no paper and pencil. I'm going to give you a problem and you're going to try and solve it on your own in your head. 97 minus 38. You can pause the video now and just take a few seconds to think about what the answer could be without using paper and pencil. All right, now you're back. And ideally, if we were together in this session, I would ask a few people to share how they solve this problem. We cannot do this right now, but some of you might have done this. Some of you maybe thought about subtracting the 10s, 90 minus 30, 60, and maybe subtracting the 1, 7 minus 8, well, it will be minus 1. 60 minus 1 will be 59. Some of you maybe would have done something similar and just subtracted by part. So 97 minus 30, that's kind of friendly. That will be 67. And then 67 minus 8 could be 59, or it is 59. Some of you might have used this other strategy, which is breaking or decomposing 97 into 80 and 17. Then you can easily subtract 80 minus 30 and 17 minus 8. And then again, you get 50 and 9. Some of you perhaps use this strategy. This is one of my favorite strategies. It's called compensation, where you try and change one of these numbers into a friendly number. So I'd like to try and change my 38 into a 40, which is way friendlier. So whatever you do on the 38, you do it on the 97 as well. So 97 plus 2 is 99. 38 plus 2 is 40. So in one quick step, we can solve 99 minus 40. Some of you perhaps did, well, this orange one is very similar to the blue one, where you subtract by parts. 97 minus 30 is 67, 67 minus 8, right? Or you could do 67 minus 7, and then one more. And some of you might have just trying to picture the numbers and just do it in the air, right? 97. So you borrow the 1, put it here. This happens all the time when I do parent sessions. And unfortunately, the only strategy that they go to would be this algorithm, and they try and do it in the air. So the algorithm is not a bad strategy. It's actually an efficient strategy, but it's not always the most efficient strategy. So as you can see, there's a ton of strategies, and whatever makes sense to you, that's the one that you could be using when the numbers are as friendly as 97 and 38. So I always try and recommend that you start your math lesson with a number talk like this. And it's only a 7 minutes, 8 minutes little warm up before your class, where you give your students a problem like this, try and solve it mentally. And it could be an addition, a subtraction, multiplication, division, etc. Of course, choosing problems that are easy to solve mentally. And number talks are a phenomenal way for students to see, number one, that there are many ways to solve a problem. That will be one. And number two, to learn to understand that you use numbers flexible. You can break the 97 into 90 and 7. You can break the 97 into 80 and 17. And you can also change the 97 into 99 and the 38 into 40 if that's what you need to do. Is that how your brain thinks about it? So if you want more information about number talks, on my blog, I have a whole article on number talks, and I have a few resources that are very, very useful for when you're starting to implement number talks. There's many websites you could use, and there's a couple of books from Sherry Parish, depending on the grade level that you teach. There's one for elementary, one lower elementary, higher elementary. So I recommend that you take a look at that. It's Number Talks and it's on my blog. You could also just Google it. All right. But Number Talks are a phenomenal way to start giving your students the opportunity to explain their thinking and to feel confident that even if they don't know one specific strategies, there is some way, a strategy that they can use that they already know to solve a problem like this. It also shows students that yes, the right answer is definitely important. We need to be accurate in math, but what's most important is that you use a strategy that works for you and you learn from each other. Definitely learning from the teacher is important and is essential, but they also learn so much from each other. And number talks are a fantastic opportunity for this. I'd like to share with you about a research project, a little experiment that we did in a school that I worked previously at. We had a small group of teachers from high school, math teachers in high school, middle school, and elementary, as well as an administrator there. And we wanted to see what was the problem when students had to solve application problems, real world problems. So we invited them to participate in this challenge where they had to solve two problems. And it was the exact same problem, the exact same math topic, but one required some critical thinking, one required for them to understand what the problem was about, and the other one was a pure equation, pure arithmetic. As you can see here, none of these three students were able to solve the real world problem. However, they were able to solve the traditional problem with the exact same content. We then gave them another problem, same situation. It was the same, but one required some critical thinking. You can see it here. It was about an airplane, and it was quite interesting to see the kids taking a lot of time, using many different strategies without being able to solve the problem. But the exact same problem that was very traditional, just required an algorithm, well, they were able to solve it. So we interviewed the students and they were able to give us their opinion. If you want to watch the whole video, on the bottom right of this slide, you can see that's the name of the movie. It's called Flexible Thinking and Conceptual Understanding. It's a 5-minute video. You can find it on YouTube. It's on my YouTube channel if you want to watch the whole thing. But in this interview, we asked the students, why could you solve this problem but not the other problem? And as you can see here, one of the students said, well, because I know how to solve equations and follow steps, but I don't really know how to put the word problems into something I actually know. I learned the system of equations and I memorized it, but I don't know how to apply it into word problems. Another student said, well, I know that one problem required critical thinking and the other one was just a simple equation. Equations are easy if you know how to do it, but problem solving requires critical thinking. It's very, very interesting. So none of the students were able to realize that it was the same problem. So in this experiment, we learned a lot as teachers. We shared this little research with our parents when we were trying to shift the approach that we were using to teach math, teach and learn math at our school, because do we want our students to do more than just calculate? Do we want them to be able to do more than just use equations? And the answer is yes. All of our schools have a very clear mission, a very clear goal. We want our students to be problem solvers. We want them to be critical thinkers. We want them to be able to use everything they learn with us to make this a better world. So, how can we do that? We know that the way we're learning math, the way we're teaching math is changing, is different from how we did it in the past. So, what are some of the things that we could do in our classroom to have a better approach to teaching and learning math, to help our students be good at math, not only at the elementary level, but in the middle school level and high school and beyond? Most of the elementary teachers are very passionate about teaching, reading, and writing. And not a lot of teachers are very excited about teaching math. And maybe it's because they didn't understand math when they were young. Most of the math in elementary could be memorized. But when you get to algebra, when you get to middle school, when you get to high school, that's when you require some critical thinking. And if we don't help our students make these connections, they will be at a disadvantage. So let's talk about a balanced approach to math. We understand that the way we're learning math is changing. So, like we can see here, concepts and procedures, that's our content. The content is the same, the content doesn't change. Either if you're using Common Core standards or Texas standards, the Australian curriculum, the Ontario curriculum, it is the same content. That's not changing. What is changing is problem solving, the opportunities we allow our students for problem solving in our classroom and in our assessments. Modeling, how are students showing this work? How are they able to use visual representations to show their thinking? And then, of course, communicator and reasoning. We want our students to be skillful communicators. That has to start in the classroom. They have to be able to explain how they solve. So when an administrator walks into our classroom and they ask the students, what are you doing? Ideally, the students would say, well, I'm solving this problem, or I'm figuring out this fraction, or I'm drawing circles to make different groups to see what, all of these things that involve figuring out what is happening in that problem. I hope students don't say, well, I'm studying fractions or I'm studying common denominators, because that is not really making sense. These are the standards for mathematical practice in Common Core, but I know that all of the other curriculums as well have some sort of standards that go in alignment with the content standards. We are all very familiar with this, making sense of problems, reasoning, constructing viable arguments, etc., etc. But how are we doing this in our classroom? How are we allowing students to not only go for the right answer? These are the math claims, which are the exact same thing as the standards that we are so familiar with. But instead of having 8 of them and keeping track of all 8 of them, they have been put together in these 4 claims. Concepts and procedures is what we just talked about, all of the content. Problem solving, that is different from word problems. We're going to talk about in a moment. We're going to talk about that. Problem solving involves critical thinking, not just solving a word problem. Communicate and reasoning, where students are able to convince you or their partner that their answer is the best, that the way they solve the problem makes sense. And number 4, modeling and data analysis, right? They can make sense of a problem. They can try and come with different scenarios and construct different models to solve and interpret these problems. So in the past, we used to have all of these worksheets, right? And the worksheet you see on the left is teaching students or is requiring students to solve this division problem using an algorithm. And it has the little keywords in there, DMSB, which is divide, multiply, subtract, bring down the next number. But it's not the only way to solve this problem. For example, in the problem 74 divided by 2, students could make sense that dividing by 2 is half. So half of 70, they could easily tell you 35, and half of 4 will be 2. So 37, there is no need to use the standard algorithm for that problem. Or 85 divided by 5. Some students will be able to tell you what 85 divided by 5 is without doing that. So there are times where an algorithm for division could be the most efficient strategy, but not all the time. Eventually, when students start solving problems of division with large multi-digit numbers, they will use a calculator. There is no need to use the standard algorithm. Look at the worksheet on the right. I mean, I look at that and I don't understand exactly what the purpose of this is, especially when I see fractions like 107. Like who would use fractions of 107 or 17ths? Those fractions don't make sense. They're teaching a rule, and there's so many of them. Perhaps we could take 3 of these and have students practice, but there's no need to use some repetitive work. So this is the 2 types of standards that we are looking for, right? Of course, we have our content standards. What is it that kids need to know at this grade level? And then we add the mathematical practices, which is how our students are going to show us that they are proficient in mathematics. So math has not changed. The way we teach math is changing because we know now, thanks to Dr. Joe Boller, for example, huge on researching how students learn math best. We know that students learn best when they can visualize, when they can explain their thinking, when they can connect ideas or connect different strategies, when the math that they are solving makes sense to them. There's a lot of research that shows that memorizers are the lowest achievers in high school and university. We cannot allow our students to only rely on memory to do good in the math test. We need to help them to understand that math makes sense and it's a beautiful subject if you allow yourself to be vulnerable, to learn from each other and try different strategies. So let's take a moment to think about, how do your students learn math best? How do you learn math best? What kind of experiences would you like to give your students? Think about it for a few seconds. You can pause the video now and come back when you are ready. Let's continue talking about a balanced approach in a math program. Here we can see all of the different elements. The procedural fluency is how the math works. Yes, there are different areas at each grade level that students should be fluent with, but it's not the only thing we need to focus on. The conceptual understanding now is a boom. Everybody's talking about it. Well, what is that? It's nothing but why the math works. Why does that make sense? Why that multiplication works like that? So how the math works, why the math works, and where the math works would be the real life application. So we need to understand that we need to have a variety of opportunities for our students to show us why the math works, how it works, and where it works. Problem solving provides opportunities for students to develop and express insights and connections about the math they're exploring. They can attempt to solve problems even when they have not learned that. I remember when I first started teaching back in Mexico, a lot of the students were guessing, do I add, multiply, do I subtract? They were just guessing which operation to use to tackle a problem. But we know today that that's not going to be useful for them in the future. They need to, sometimes they can solve the same problem by adding or subtracting, whatever is it that works for them. Here is a list of the required fluencies. Of course, this is from Common Core. The different curriculums have a little bit of varied fluencies, but it's pretty much similar. And again, this is only one area of mathematics, just one area. If you are interested in learning more about fluency, there's a great article. You can just, it's in my Padlet. It's called Number Fluency Strategy Choice by Rebecca Vukovic. It's a very good article on number fluency. And there's also this great book, Van de Waal, Teaching Student-Centered Math. And chapter 9 is all about, it's all about developing basic fact fluency. And really, the most important part of either the article or the book is that fluency doesn't have to rely on memory, but on understanding different ways to solve the problem. And eventually, students will be fluent. So we've talked a little bit about the balanced approach to math. So let's move into the student-centered approach. All right. Let's take 5 minutes to read this blog about how to use a student-centered approach in your math lesson. And when you're finished, you can pause this video right now, access this link. It's on my blog. Read the article and then unpause the video and come back. Welcome back. Let's practice about this student-centered approach. You just read the article about it. Let's see what this could look like. Get paper and pencil and find 3 factors that give you the product of 108. You can solve with a partner or solve on your own. Pause the video now and come back. Welcome back. Let's see what some of the strategies could be for a student-centered approach. The teacher didn't say anything. The only thing that he did was give them the instruction of the problem. Students went and worked with their partners, and now they're ready to share. One student perhaps would say, well, I thought about dividing 108 by 2, and I got 54. So to get 3 factors, I thought about 54 times 2 times 1. Another student could say, well, I created a table and I started with 1 times 2 times 54, or 1 times 3 times 36, or 2 times 3 times 18, etc. Some students perhaps could be able to share that he or she used prime factorization, divided 108 in 54 and 2, which is similar to what the first student and second student shared. Then continue to decompose the 54 into factors of 9 and 6, and continue to decompose the 9 and the 6 into you have prime factorization. Having that, you can do all of the combination of numbers that multiplied will give you 108. Depending on what the lesson objective was, depending on the grade level, the teacher could expect students to share the strategy that he or she had in mind for the teaching point for the day. If none of the students are able to share the strategy that she or he wanted, then this is the time for the teacher to share another way to solve, could be using these. So the point for the student-centered approach is that, yes, it could be a little bit scary and it could be a little bit messy, because perhaps none of the students will be able to come up with a strategy that you were hoping for today's lesson. However, At the end of your lesson, when all of them are sharing strategy, you are going to get the chance to share your strategy. And that's your teaching point, and not because you didn't do it at the beginning. It means that the students are not going to be able to grasp this strategy. On the contrary, students are going to know that what they did has some sort of connection with the strategy that you are sharing. Using a student-centered approach could be a little bit scary for those teachers that like notebooks to look perfect and neat and organized and only have the strategies that the teacher allows them to use. When we are using a student-centered approach to teach our lessons, the notebooks can be messy. Students can have a variety of strategies. Some are efficient, some are not so efficient, because students are figuring out the problem. Students are making sense of what they need to do. But students are gaining a lot of confidence that they could tackle a problem in many, many ways. Eventually, they will realize that using efficient strategies will absolutely help them be proficient in mathematics. But they come to this understanding on their own without necessarily only using a strategy because the teacher said that was the best strategy. Um, there are some really, really exciting things about using a student-centered approach, but of course, there are some challenges. So feel free to pause this video right now and write down what are some of the areas of this approach that you're excited to try, and what are some challenges that you might face. You can pause the webinar and come back in a few minutes. Welcome back. Some of the strategies that the student-centered approach refers to are called invented strategies. And these strategies are the strategies that come from the students. When you give them a problem, when your focus is only to make the problem clear without telling students how to solve. These invented strategies tend to be number oriented rather than digit oriented. For example, in 68 times 7, students most likely will multiply 60 times 7, then 8 times 7. They focus on place value. They're left-handed rather than right-handed. For example, 52 times 46, again, they start with 50 times 40 and then move on from there. There are many flexible options for these strategies. There's no one way to do that. For example, 7,000 minus 25, you don't have to use an algorithm to solve this problem and change all those bunch of zeros into tens and nines. You can make sense of 7,000 minus 20, then minus 5. For the second example over here, 567 minus 148, again, using a strategy like a friendly number where you add 2, 569 minus 150 is way more efficient than the algorithm of the subtraction. Here's a picture of an area model. The area model is introduced in grade 4, and it's a strategy that students come up with on their own. So a lot of the times when a student comes up with a strategy or is trying to make sense of a problem and has parts of this, you can name this strategy the name of that student. So if you have a student named Lily and she's the one that came up with this strategy, you can call it the Lily strategy. Put it in your chart, in your anchor chart, and you will be surprised at how many students use that strategy, the Lily strategy. Eventually, you can, of course, share with the kids that this is a very efficient strategy and it's called area model. And little by little, they start referring to it with the appropriate name. There's many benefits of invented strategies. There's a number of research studies that have focused on attentions on how learners of a variety of ages handle computational situations when they have opportunities for many strategies, for multiple strategies. They make fewer mistakes. There's less reteaching required. They develop number sense, place value. They use their mental understanding of the problem before just going to the computation with the algorithm. It is very good for students to feel confident in these skills when they go do tests. They're less anxious, they're less stressed about tests because they know that they can solve it in a way that makes sense for them. You can take a look at the research, take a picture, take a screenshot if you want to go deeper into these research about multiple strategies. Here are some student samples. In a moment, we are going to see what a student-centered lesson looks like. And one of the parts of the lesson is looking at a work from yesterday, right? I call it look at the work from yesterday. And so that is when you can share some of the strategies that students used yesterday. And it could be some strategies that are really good and really efficient. And students are very good about observing these strategies. What do you notice in these strategies? Oh, well, I notice how the 18 is in one row and the 13 is the other row. So it's easy for me to do that. Or I like how the person in the second problem used all of the tally marks and then crossed out the ones that you're going to subtract. That's easy. And so all of these strategies are very good because kids make sense of why they're good. Notice how when sharing student samples, it's important that you cover the name of the student. Because sometimes you could choose a piece of work that has a strategy that is not very efficient, and students can talk about it and they can make sense. Why is that not the best strategy, right? Using tally marks, for example, in that sample on the left is good, but when you get to higher numbers, using tally marks is not the most efficient, and students could make sense of this. Here is an idea of how you can collect data on invented strategies. Just like we collect data on what students are doing well and what they're showing proficiency of, you could collect data on which strategies they're using. If you notice there are some students that are only using one strategy, you could talk to them during the active engagement of your lesson when you're conferring with them, and you can encourage them to use different strategies, right? But if you have this data, if you have all of the strategies that are allowed in your classroom, or all of the strategies that have come up, then encourage students to try a variety of them. We have talked about student-centered approach in our lessons. We have talked about the 4 essential elements of a balanced approach. So what does this look like? What does this look like in the classroom? All right, let's take a look at this example of this lesson. All right, have your Post-its ready so you can have some feedback or some questions about it. This is a lesson for grade 3. And I have the lesson objective as the first slide. I like to have the lesson objective for the students a little bit more general, not so specific about what students exactly should do, but just solve math problems and show how you solved or something like that. The lesson objective for the teachers, you can see on the bottom, I usually put it on the notes of the PowerPoint. So it's solve 2-step word problems using visual representations. Your teaching point could be very specific, using number lines to solve subtraction problems, using double number lines for whatever. But if you put that as your lesson objective for students, then they're all going to be doing that instead of exploring different strategies, which is what we want. So part 1 of our lesson is a number talk or a warm-up. And for those of you who are very familiar with reading and writing workshop, I use a math workshop approach. It's the exact same thing and it's the exact same for parts of a lesson. So you'll be able to make a connection here. This part one is the connection. It's 5 to 7 minutes and it's just a warm up. For this lesson, I used a splat. This is a great resource. You can take a picture of these or write it down in your notes. A variety of splats are made by Stevie Wyborny, and I really recommend it. He has for all grade levels up to grade 8. This one is for grade 3, so we will start with how many blue dots do you see? Give them a few minutes or a few seconds, and students can write down their answers or say their answers, and then splat. There are 2 splats that are different colors, and when they're different colors, it must be that they're covering different numbers of dots. How many dots could be under the green splat? How many could be under the yellow splat? What combinations are possible? Students can talk to each other before sharing with the class, practicing their answer, practicing how they're going to say the answer. I always make sure during a number talk to give the kids opportunities to tell a partner first. This is a very good strategy for EAL learners so they can practice how to explain how they solve. And if there's a student that perhaps doesn't have the answer, maybe they can, after listening to their partner, they can make sense of that and share that strategy as well. Let's look under one splat to see how many dots are there. And then students figure it out. So there's a few different number talks that you can have, not only with the operations, but with some exercises like this. I have a variety of number talk resources on my Padlet. Go ahead and take a look at that. Some of the work from yesterday looked like this. Right after the number talk, this is where I put pictures of some of the work from yesterday. Some strategies that were very good, perhaps a strategy that was not very efficient. Sometimes I solve the problem on my own and I share the strategy here. And I say, well, yesterday when we were solving this problem, I used this strategy. What do you guys think about? And students make sense of the strategy to see if it's a good strategy that they would like to try or not. Part 2 of my lesson. That's the mini lesson. That is exactly your teaching point of the day. You finish your warm-up, and now we are ready for it. The difference in literacy, in the literacy workshop, in the reading and writing workshop, and the math workshop is that you're not going to tell the students in your mini lesson how to solve the problem. You're going to talk about what the problem is about. So you start with your problem and notice how I'm using slow release. This is also a very good strategy for EAL learners or for learning support students that could get a little overwhelmed by a whole problem in that moment. So Ryan has $173 in the bank. Slow release, he earns the same amount for 7 weeks, puts it in the bank. Slow release, next sentence. Now Ryan has 208 in the bank. What could the question be? Students go crazy thinking about all of the different questions that could be asked. Fantastic. Then you give them the question. How much money did Ryan earn each week? And that's it. This is your mini lesson. You talk about what does this mean? What does the word earn means? Clarify that is for 7 weeks, the same amount for 7 weeks, etc., etc. And after kids are very clear about what the problem is about, that's part 3. That's the active engagement. This is the big chunk of your lesson, 15 to 20 minutes, where students are working, hopefully in pairs or in groups of 3, trying to figure out how they're going to solve the problem. You didn't tell them what strategy to use. You didn't tell them exactly what they need to do. They are trying to figure it out. What are you doing during part 3? You're walking around. You're conferring. You're checking to see how many strategies are students using. This is where you could differentiate. If you see a student that is finished in a few minutes, you can go talk to them and say, oh, what if instead of 7 weeks, it could be for 6 months? Could you figure this out? If you see a student that requires a little bit of reteaching or a little bit of support, this also could be a good time for you to have a small group and work with them. This is the type of layout I like to give students so they can have a lot of the page for using the strategy. Look at how it says there, show how you solve. And then I usually give them a little space in there to explain their thinking. If we are going to be assessing how they're communicating, how they're explaining, we need to teach that as well. So that will be a whole lesson. And I would have an anchor chart in my classroom that gives students ideas of how to explain how they're thinking. Don't expect students to just know how to do this. We have to teach them explicitly. Well, these are some words that you could use. First, I did this, then I did that, etc. So if you're assessing the communicating piece in your math assessments, then you need to have opportunities during your lessons for students to practice that. And then we're ready for part 4. Last part of the class and the most important part, the share. This is where the teaching happens, and it's about 15 minutes. So you always make sure to stop your lesson 15 minutes before it ends so you could have enough time for the share. I have a whole blog on my blog site that is called The Essential Component of a Math Lesson, and it talks about only the share, how to do your share, what are the questions you could use, what are the strategies you could use. So go ahead and write that down on your notes. In the share, what do you do? How did you solve it? Students come back to the carpet and share all their different strategies. They can come up to the front and show their work and explain how they're solved. Or they can share from their place and you as a teacher model on the board using a visual of the strategy that they use. When students finish sharing, then you could go ahead and say, well, another way that we could solve it could be like this. And this is where you teach the strategy that you had in mind. If it didn't come up here where students were sharing, this is your chance. And that's it. The lesson is over. And I have this template of the slides that you could use to plan your lessons on my Padlet. So go ahead and take a look at it. It just has the 4 parts of the lesson, so you can just follow it. I usually put an extra practice or an exit sleep in here, right? So the same type of problem. So if you have some students that finish a little bit earlier, right, your high flyers, then you can have an extra problem ready for them. And that's it. Your lesson ended. I hope you're feeling a little bit ready to create a lesson using a student-centered approach and allowing opportunities to problem solve, model, and communicate and reason. So there's one more thing I wanted to share with you on this webinar, which is just going a little bit deeper about this problem solving and modeling. The concepts and procedures, I think we have it very clear. It's the content, right? It's what kids need to know. And it's, of course, driven by the standards that your school is following. Communicating and reasoning, right? Students have to convince you that the strategy is their best, how they did it. They just explain the different steps they use. Problem solving and modeling are the 2 components that I'd like to talk a little bit more in depth. So let's talk about problem solving first. Problem solving is opportunities for students to really have some critical thinking about a problem. So this one right here, this sheet, is showing you how many cookies there are. It's showing you that there's 3 rows and that there's 5 cookies on each one. So there's absolutely no thinking needed. The students can just count and know that you have 3 rows of 5 cookies, 3 times 5, or 5 plus 5 plus 5. They can even count one by one with their fingers. So some people think that problem solving is when you have a few words, but actually problem solving would be something like this. I have a cookie recipe that makes 24 cookies. In how many different ways can I arrange the dough on a cookie sheet? So students go ahead and think about it. They talk to their partner. They can share with you. Some students would say, well, you can have 3 rows of 8 cookies. Yeah, you could have that. Some other students might say, well, you can have 6 rows of 4 cookies or 4 rows of 6 cookies. Perfect. Maybe somebody would say, well, you can have 2 rows of 12 cookies or 1 row of 24 cookies. Yeah, all of those could be possible. Who in this classroom has an oven or a cookie tray that fits 1 row of 24 cookies? Well, everybody's going to laugh and understand that there's no such a thing. We don't have a cookie tray for 1 row of 24. So even though the factors 24 and 1 and 12 and 2 are correct, might not be the best answer for this problem. And that is problem solving. Look at this problem right here. Anna has 5 gummy bears. Billy has 7 more. How many do they have in all? What do they have to do? Just 5 plus 7. It's the same as giving them just the basic fact of 5 plus 7. Not because there are words, make it problem solving. Look at a problem like this. Again, using slow release. Anna and Billy combine their gummy bears to share with each other. They have 12 gummy bears all together. What would you like to know? You pause right here. This is in your mini lesson. Students want to know how many are strawberry, how many are lemon, how many are these, who has more, many things. How many do they each have? Yeah, let's find out how many bears did each of them have. How many gummy bears of each color could they have? Yeah, we could do that too. And explain how you found the answer. Lots of strategies, lots of answers, lots of thinking. That is problem solving. Now, modeling. What is modeling? Modeling is everything that happens between the question and the answer. Look at that. Between the question and the answer. For modeling, we should be starting with giving our students concrete representations of whatever math concept we're talking about. We're starting with base 10 blocks. You start with unifigs. You start with counters, whatever it is that is concrete, that students can touch, can manipulate to build understanding of what that is. Then we move into a pictorial representation, more a visual representation, very similar to the concrete, but a next step. After that, students will be able to move into a more abstract representation. If you look in here, this is for grade 5. If you're multiplying 0.2 times 0.4, that will be 2/10 of 4/10. Multiplication means of. So what is 2/10 of 4/10? So if you look in the concrete, the 4/10 will be the green. In the pictorial, you again have the green be the 4/10. Now, what is 2/10 of that? And you can see right there, that will be 8. 8 of those little things will be 800. So little by little, students will be able to make sense of that. Look at this one, 0.5 times 2.6. Using an algorithm is not the only way of solving this problem, and you moving all of these different decimal points to the right and the left. You think about 0.5 is half. Half of 2.6. What is half of 2.6? Well, that will be 1.3. But we need to trust the model to be able to use modeling. There's a lot of students that use fake modeling. They get a problem, they solve it using an algorithm or mentally, and then they draw a picture of the answer. That's fake modeling. Real modeling, again, is happens between the question and the answer. So we need to provide lots of opportunities for students to model and to trust the model, to know that, yes, you can solve a problem through modeling. Here's another good example of modeling. Student is subtracting 53 minus 36. So started with the manipulatives, started with 53, and now has to remove 36 of them, right? Using these type of concrete manipulatives will give students the understanding of what subtraction is about. This one right here, fake modeling. The student used an algorithm, you can see it right there, and then drew a bunch of little tens and ones. I mean, it looks good, but those base tens did not help the student solve this problem. It's just a picture. This is another good example of modeling and fake modeling. On the picture on the right, you can see the kid had 52 base 10 blocks and divided them in 4 groups. So probably had to decompose one of the tens, one of the green longs, into some ones. And then that was the one way to divide it into 4 groups of 13. The other one, well, you have the 52 divided by 4, and yes, did 4 groups of 13, but how did that come up? How did that 52 magically became 13, 13, 13? Perhaps the student knew 13 times 4, and that's okay. If they're able to explain to you that they know the times table 13, then that could make sense. That's why communicating and reasoning is such an important part of our lessons as well. I have this video that I'd like to show you. It's about the progressions of algebraic thinking. Again, I did this video with another partner from a school I worked previously at. And it's on YouTube. You can just type these, modeling algebraic thinking, CCSS, from grade 2 to high school. It's again on my YouTube channel. Take a look at that. It's pretty good. And it shows you these manipulatives, these concrete manipulatives, how they're used with the exact same model, like very similar model. And it develops different mathematical concepts for all of the different grade levels. And this enables students to move from the concrete stage to the abstract stage, and then leading at the end to mathematical fluency, which is what we want. Research shows that going from concrete to abstract leads to fluency. It really shows the connection in how students learn math at the different grade levels. Also, there's a variety of videos from Graham Fletcher. I'm a big fan of Graham Fletcher. He has done a great job about making videos that show this progression. So if you go on his website, gfletchy.com, you click on the progressions, and he has for all of the different grade levels. The fractions one is amazing. It starts with grade 2, and what students starts learning about fractions, and it goes all the way. I truly recommend it. He uses counters, he uses base tens, he uses a lot of area model pictorials, partial products, algorithms. So go ahead and take a look at that. And this is it for today's webinar. I really hope that you have learned a few things that you could use in your classroom tomorrow, that you can put into practice. Again, we cannot change everything from one day to the next. So choose what is it that you want to work on. Do you want to work on number talks? Then go ahead and do a little bit more research about number talks. I have that blog on my blog site. There's a lot online. You can just type number talks. You can get Sherry Parrish book. and you can really dive deep into that. Very important that you keep your number talks short, because we tend to get very excited during number talks, and then you don't have enough time for your lesson. So eventually you end up cutting the number talk. So in order for that not to happen, just make sure that you intentionally plan it for 7 minutes, and then you move on with your lesson. If you want to work on the student-centered approach, just take a look again at the blog so you can really use the 4 components of the lesson. You start with your number talk, you go with your mini lesson, and then the active engagement and the share. And just be very intentional with the way you are allowing students to problem solve and model in your classroom. If you really want them to be problem solvers, then take a look at the problems that you're giving them. And just if you're following a workbook, or if you're following a curriculum that is asking you to give them problems and problems and problems, just number problems, then tweak a few of them and change those problems into problem solving. You don't have to come up with a new workbook or a new curriculum. You could use what you have, just change it a little bit for students to have opportunities to come up with different ways to solve it, to come up with different strategies and share their strategies. Modeling too, you have a lot of resources in your classroom. Don't tell kids exactly how to use them. Just give it to them, give them the problem. And when it's time to share on that 4th part of your lesson, that's where you could share, well, we could use the manipulatives like this. This is how we could do it. Be very intentional with providing your students with opportunities to explain their thinking. Remember that the person doing the talking is the person doing the learning. If you are talking throughout your whole lesson, you're probably just learning more and more. You have to give students opportunities to talk to each other, talk with their partner, then talk to the class, then write it down, make connections, explain, use all of these visual representations and explain how you use them. That is how we are really going to be able to have these great people be the mathematicians that we need to change our world. So I'd like to finish this webinar with this quote from Karim. Karim, he has a great website right there. You can see it. And I love it. I love it. It's very inspiring. These people are going to make the rules for our countries, for all our different countries. Math is the perfect platform for students to be problem solvers, to be critical thinkers, to be skillful communicators. It's a tool that people need to make sense of what's happening in the world and how to make changes. Hope you liked it, and follow me on Twitter and follow my blog, and hope to see you again. See you later.